I'm Tim Shatney, and in this video I want to show you how to create a dry-wet control for any kind of audio effect you would want to build. Here we have already this delay audio effect which we created last time. We can change the delay time for both channels separately, change the feedback amount, and even the frequency shift there. Great. So let's add here the dry-wet control. We open the editing mode, and here we can see that we have these two patch cords which connect directly the input to the output, which is a dry signal. And then here these two patch cords go to these two delay lines where we have a processing of sound, and here on the output we have two wet signals which go back to the output, to this plug out object. So somehow we would need to control the volume between these two and these two. It means, first of all, we need to create a multiplication object for signals and to insert it here, here, and then here and here. And now we create a dry-wet control with live dial. I make an amount prototype and then modify it in inspector, just giving another name, dry-wet. And then change the range between 0 and 1, also making it float. And then we have a perfect dry-wet control now. And with it, we already can control the output of our wet signal. So now let's make this linear interpolation, like this. And then connect the line tilde object to these two multiplication objects of wet signals. So, I forgot to move it here, so we can use it actually. And then we see that it works. We also hear that it works. Now we need somehow to control with the same knob the amount of a dry signal. So to do this, we could use, like in our previous lesson with frequency shifter, we could use this reverse subtraction operator like that. And then here, with this phonom object, we could see the outputs here and there. We could see that when we have here 0, we would have there 1, and also in another way, when we have here 1, then we have here 0. And so this output we could also linearly interpolate and use for the multiplication of a direct signal, like this. So now we have a pretty good dry-wet control, but there's one problem. And this problem is that when we have dry-wet about 0.5, then we have a drop in energy. Both signals start to be softer and we kind of lose the overall energy after our processing. Notice how this volume of a signal rises when we go to one of those extremes. Either it's full wet or full dry. So I go back to 0.5 and then now I go to full wet. Go back to somewhere in between and then go full dry. So it's obviously we have this problem of losing energy in between. And that's why I want to show you the second way of creating a dry-wet control. And for that, we would use some trigonometric functions. Okay, so this method works. You can remember it, but you know that there's disadvantage that we lose some energy. If you want to get away from this process of losing this energy, we need to use these trigonometric functions, and in this case, it would be a sinusoidal function. That's why we use the cycle object, which is sinusoidal oscillator, and actually it's a wavetable sinusoidal oscillator. It means that we can read from its wavetable different values. And since it's a cosine wavetable, it will start from 1 and end also with 1. So I have here this cosine on the graph, and then you see here it starts from 1 and then goes further here. Somewhere in between we have again -1, and again it's here in -1. maybe here is even better, more clear. -1, 1, and this is a cosine. That's what we have here. And if we would send this driver control to the second input of the cycle to control its phase, then without specifying the frequency of the cycle, on the output of it, we would get exactly these numbers from this wavetable. So let's look. We start from 1, go more and more and more. On 0.5 we get -1. Not really, but about it. And then at drive at 1 we get here again 1. So we kind of insert here the x value and we output the y value of this wavetable. And with this we could get kind of the algorithm which would save the energy even when we have a drive at of 0.5. So firstly I create it and then I explain it. Now we create a scale object to use only one part of this wavetable. I want to scale the input which is from 0 to 1 to the range between 0 to 0.25. And then I would get now, when I change this knob, develops between 1 and 0. And then I copy this same thing, connect also with drive and change here the output range to 0.75 to 1, like this. And here with this number tilde we could see that now we have pretty much kind of the same thing as we had with this inverse subtraction, but when we have 0.5 for dry this is not actually 0.5 for both. It is 0.707, which is about -3 dB for both dry and wet signal. And that's perfect because this would give us a feeling that we always save energy between two types of signals. So we just then connect the first here to the dry multiplications and the second cycle we connect to the wet multiplications. And this dry wet control I just move here and we could test now that it works. I close it and then you could hear that it's an equal power dry wet control. No more feeling of losing loudness in the middle of dry wet, and it's great. So we created it, we used these two cosine wavetables to generate this beautiful energy distribution and make this dry wet control absolutely perfect. So you could save it somewhere, for example, as a snippet and reuse it in many of your audio effects. Thank you for watching. I hope it was helpful and would see us in the next video where we would talk about presentation mode to make our audio effects beautiful and clean. Bye bye.